and incoming mail as spam or normal. This is normal, this is spam, two cases. Okay, so in these cases, how to classify, how to learn a model. So as I said, Navier Bayes is a probability based. So so P of n. So here what happens based upon the information, like how many words, if a mail is classified as a normal, how many words are dear. Suppose past data. So these are all past data. Suppose I have past data 10 mails of normal mails. In that normal mails, how many dear are there? How many friend are there? So like that, for each word, I will have a probability. Similarly, I have 10 mails which are classified as a spam. In these spam mails, how many words are classified as dear? How many words classified as a friend? There may be a common words, or there may not be a common words, right? So in those cases, suppose if a new mail comes with the dear, friend, okay, or some words, hi, how are you, something like that, how to classify this mail, either as a normal or as a spam. So that's what we need to study. Okay, so what we will do, it is based upon the a priori probability. A priori probability means, suppose if I receive 20 mails, okay, before solving a problem, this particular problem, I got 20 mails. In these 20 mails, how many are normal, how many are spam? In the normal, how many words, dear, what is the probability, how many words are there, friend, how many words are there? Okay, so like that we will compute the probability. If the see, out of 20 mails I receive, 10 mails, okay, or else 15 mails are normal, 5 mails are spam. Now what is the probability of normal? 15 by 20. And what about this one? 5 by 20 is the probability of spam. In that, we will look into each word probability. So which is highest probability? See, probability of normal, if it is a normal, what is the probability of dear? If it is a normal, what is the probability of a friend? So like that, we compute the probabilities of each word. Similarly, his spam also will compute the probability, and which probability is greater, we will assign the label as either normal or spam. Okay, see here. So we got some set of mails. Okay, we receive eight messages. We already know, based upon our experience, we know that eight are uh, normal. Okay, and 4 are spam. A priori information. Next, and when I open all the normal mails, I found that dear is a word dear present, and these many times. Friend is present these many times. Similarly, lunch and money. In this case also, we have dear, friend, lunch, money. In spam case also. In this case also. Okay. So see, lunch is not present here. Like that, there may be some set of words, some whatever it may be, some arrogant words, whatever it may be. So there are some set of words. In normal also, we have some set of words. For each word, we will complete how many times it occurred. In case of normal, and in case of spam. So what we will do, when we receive a word, okay, then we need to check. Okay, how we will check? See here. So we will check for, see here, dear. Okay, probability 8 by 17, 0.47. See here, 1 2 3 4 5 6 7 8. 8 times dear occurred out of 8, 9, 10, 11, 12, 13, 16, 17. So what's the probability? Dear 0.47. 0 for friend, how many? 3, 5. 5 by total. Okay, 0.29. This is 3. This is 1, 0.06. So for which are the words present? Which are all the words present in the normal mails? These are all the normal mails I received. From each mail, I will count and I will compute the probability of each word. Similarly with spam. Then what I will do, suppose if a mail comes and I want to classify it as a normal or spam. Next, what I will do, first probability here. How many mails I received at higher level, normal or this one, spam, probability of n. So what is that? How many mails are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 mails out of 12 are normal. 4 mails out of 12 are spam. Okay. Next, I will open the new mail and I will check what is the word here and what is the probability of the word if it is normal. What is the probability that if it is spam? Like that, I keep on computing the values like this. If it is a normal, what is the first word present in my mail? What is and its probability? What is second word, third word? Like that, for a new mail, I will compute the probability of all the words. Similarly, for second spam also, I will compute all the probabilities. Then which probability is higher, I will assign the class. Got it? It's very simple. Based upon the prior probability, prior information, we will keep all the data ready. Whenever I receive a mail, what is the normal mail? What is the spam mail? And if it is normal, I assume that if it is normal, dear, how many times it occurred? Sometimes some words, this is lunch. Lunch is 0. Okay, we will ignore that. So like that, what we will do for each word, we will compute the probability, and whichever is higher, we will assign the task. See, so number of normal messages is 8 by 12, spam messages is 4 by 12. So what we will do, if it is normal, so if it is normal, then how many times dear occurred, how many times friend given a normal, this is 0.09. So here also same thing, okay, 0.01. So what is highest probability? 0.09. I received a mail, dear friend is the mail I received. So this mail, dear friend, I need to classify as a normal or spam. So what I will do, based upon my a priori probability, we have these are the classes 3 plus 5 8 4. Okay, so what is the probability of normal? 0.67, 8 by 12, spam 0.33. So 0.33, sorry, 0.67 is my normal. In that, dear is the word. How many times dear occurred? 0.47. How many times friend occurred? 0.29. So overall probability 0.09. Okay, next 0.33 in case of this one, spam. And how many times dear occurred? 0.29. This dear is this dear. Okay, and friend, this friend is this friend. 0.14, it is equal to 0.01, which is highest probability, this one. So this dear friend, based upon my prior experience, it is a normal mail. Okay, okay. So like that, we can compute many many words. See, money, lunch. Okay, so if it is spam, what is order? Okay, so like that we can compare. So any doubts till here? So from the morning, what we did is we started with a discussion on what actually the learning is, what is meant by learning. So in learning, what we will do, okay. So what is meant by machine learning, okay. So what is the importance of machine learning, and in that what is importance of mass, okay. So we studied all those things. So yeah, this is where we started. So any planning, and any prediction, okay, in any planning and in any prediction, okay. So we will use this machine learning. Okay, so we looked into what are the main ideas of machine learning. Ideas of machine learning are, so we can do a classification problem, prediction problem, cluster problem, etc. Okay, so in that, what is the role of statistics, how statistics impacts. Okay, so we studied various statistics problem. We also studied end to end how, what are the steps involved in machine learning. Okay, in that we focused on building the model. In that we focused on building and learning the math behind each model. Okay, so this is how. So whenever we are telling about a model, we need to learn a mathematical equation. In that, learning means this learning the weights and bias. And we look into various scenarios. Okay, so what are those scenarios? So regression we can do, classification we can do. For this classification, and for this classification, we can build a linear curve, or we can build a regression tree. So for building regression tree, we need to follow some set of mathematical operations. For building a line, we need to follow some set of operations. So here we will use gradient descent, which is not the case here. Okay, so like that we have seen various cases, and which are all the normal jargon or normal terminology we use in machine learning. And so we use like what are the algorithms? If my data is linear, so what are things I can do? If it is a tree based, what are things? Okay, and if it is a neural network, what we can do? Okay, so these are all the complete mathematics for each. The linear equation is this one, so there is a mathematics. If there is a logistic regression, this is the equation. Okay, so if we want to build trees, Gini index, impurity index, Gini index, entropy are the useful things. This is a logistic regression equation. This is gradient boosting equation. Okay, random forest, Navier Bayes, just we have studied. This is the probability information, and this is the neural networks. So if you see any network, the inside, the background is mathematics. So that's what we completely focused in this lecture. When I say linear regression, building a line, and there is some formula. Logistic regression, so logistic regression is like this. There is a mathematical formula, impurity index, to build the tree. So in any case, we need to focus on the mathematics. So even though we have very simple functions, because of the well curated, well available, means well structured data, these logistic regression things may work. But in real time cases, in real time data set may contain a lot of noise. Okay, lot of errors, lot of imbalance, so which makes usage of these built-in functions not much suitable for this data. We need to do a lot of hyper tuning, lot of modifications, optimizations we need to do. For that, we need to understand the uh, black box. Okay, so ultimately model represents the equation, and then we need to learn the weights, parameters. So we look into fundamental concepts. We can start with histogram. Without using any mathematical formula, we can use histogram, or we can use histogram, or map the data into distributions, probability distributions, binomial distribution, or Poisson distribution, and normal distribution. So each distribution will have a mathematical formula, which itself a model. So this itself a model. Okay, so this is one model. Clearly, in case of Poisson distribution, this is a model. So like that, in case of Gaussian distribution, we have one more mathematical equation, this one. So this is a model. So without learning anything, if luckily if data suits the distribution, we'll get a model. If not, we need to come up with our own equation. So we started with linear regression. So we studied how to build a line, optimal line with set of data points. For that, we need to compute two unknowns, that is M and C. So how we compute? We compute with the help of a errors. Few metrics are there, so metrics help us to come up with the best fit. Okay, so how to, we need some more guidance. So in these errors also we observed simple metric is residual, that is observed minus predicted, and then we have seen sum of squared errors, and then we found mean square error, because every metric is having dependent either on the x-axis, that means number of observations, or on the y-axis, that means the matrix. Okay, so then we computed a metric called r square, which is independent of either x-axis or y-axis. So there what we will do, we will use the average of the y-axis, mean value, and the line which we fit, we will check how much it is deviated. So in that case, what happens, same metrics we are using, so there is no impact of either y-axis or x-axis. This is the formula for r square. Okay, so these are the formulas. So next, what we did, gradient descent. So gradient descent, why we need gradient descent? It doesn't mean that always all the cases we use a simple line. Sometimes we need to fit a non-linear curve. Okay, so in gradient descent, what happens, we need a help how to move. Okay, so the direction we need to move, either slope or this one. In predicting new values, we need a support or guidance. So that will be given by the tangent line to the point. So this tangent line will give me the idea about how I can move. So that is called gradient. Okay, so we studied by default 0.64 how to find out the best intercept. Okay, and then this is the formula. We need to find out the intercept, and how the intercept will have impact on SSR. There will be a formula. Similarly, we also computed how slope will have impact on the SSR. So those two formulas we have used, and so slowly we started with 0 as initial value and 0.61 as a fixed value, and we computed by plotting the gradients. And then what we did, once we choose how to come up with the best slope value, best intercept value, then second expression, we also learned how to find out the both intercept and slope. In that case, it will be a three-dimensional space. not a two-dimensional space. So for that also we have two set of equations involving both intercept and slope. This is for intercept with respect to SSR, and slope if you want to minimize the SSR. So these two values. So here also we start with initial values 0 and 0.5, and slowly we apply the formula which we have learned in the previous session. So slowly it will optimize somewhere, it will find a point which is minimum. Okay, and then what we did, we studied decision trees. So decision trees, we need the leaves or the labels, and the interior nodes or the features. So we need to find out the split up criteria and which feature we need to select. So in that case, we two parameters are the metrics we need is Gini index. So Gini index will help us to find out the best leaf. And we also see in the regression type. So regression, we keep on moving from left to right and finding out the average values. The average value of the tree must match to the real-time scenario of the table. There, then we will stop the criteria. Okay. So this is the regression tree, and then we studied Naive Bayes. So Naive Bayes is based upon the previous experience. Based upon our experience of past data which we receive. So we will compute the probabilities, and whenever new data comes, like dear friend, we need to classify based upon our previous data. Okay, so like this we studied and we computed. So this is a very excellent book. The slides are from this book. Okay, so I just adjusted. So this is a very nice book. If you want to learn, you can use this book. So any doubts still here? Okay, yeah, thank you.
Okay, so thank you, Chandra, for the session. I know it was quite hectic to have a session, continuous session, so we really appreciate that. So, and thanks to all of you. So we will wind up today's session. So maybe tomorrow's session we will start at 10 o'clock morning. So again, we expect